Hello guys, welcome to another project that we are going to solve by using reinforcement learning or perhaps deep reinforcement learning. So far you might be wondering that we always solve a problem where a game is involved. Is RL really just related to games? The answer is no. It is not just related to games. We usually solve game related problems in RL. Why? Because games are mostly executed in simulated environments, and reinforcement learning is very useful in simulated environments. However, just to demonstrate that reinforcement learning is pretty much useful in other applications as well, we are going to work on a project called trading bot. So we are going to design a bot. In this case, bot will be our agent and bot will be doing trading for us. What happens in trading? We usually invest some money, right? Or we usually pull out our money, and in return we get some profit or we get some loss. So this is something that happens in trading, right? And bot is going to do this thing for us. So for this thing we are going to use another library, Python library, that is called Gym AnyTrading. It is much like Gym library. This AnyTrading is it actually it is sort of an extension of Gym library, and it helps us in financial projects, right? So let's jump straight into the coding. So first of all, I have already installed these libraries. All you have to do is you have to run this cell, and it will take a few minutes to install these libraries. So just to save time, I have already installed it. So let's start from right hand side. It is installing Gym. We know what is Gym. Then it is installing Gym Trading. Let me get back on Gym AnyTrading in a while. Then we are installing stable baseline. We have studied it thoroughly in previous module. Then we are installing TensorFlow, specifically 1.15 version, because this is compatible with Gym AnyTrading. And we are also installing TensorFlow's GPU version in case if someone is using GPU, right? So let's come back to Gym AnyTrading library. So here is the documentation available for Gym AnyTrading. You can read it out. This is how you can simply install it by using pip, and this is how we are installing it. Otherwise, you can install it from directly from repository, and rest of the things we are going to implement. So you can read it out, and we are going to implement it as well. Okay, actually we are not going to implement these things, we are going to make use of these things, right? So let's go and let's import a few libraries. And by the way, one more thing, we are using Google Colab or Collaboratory. Why? Because I just wanted to give you guys a flavor that we can since up till now we have been using Jupyter Notebook, but I wanted to let you know guys, Google Collaboratory is just like Jupyter Notebook, but for this in order to use this Google Colab, all you need is an internet connection, a Google account, and a browser, nothing else. You don't have to have a very high speed CPU or anything. And moreover, if you're using Google Colab, you can use free GPU as well. That's amazing, right? So, and rest of the thing is same. It works just like Jupyter Notebook. Let's say this is a cell. If I click on this code thing, it will add more cells into it, and then I can also execute these cells and so on, right? Let me increase the font of, yeah, great, so that you guys can see. Okay, so here I'm going to import. First of all, I'm going to import Gem. Then I'm going to import Gym AnyTrading. Yeah, Gym Any. I think Any TRADI. AnyTrading, right? Okay, and then we are going to. No, it is not. Yeah, I think it is underscore. Let me go over there. Okay, so yeah, it is Gym underscore trading. That's how we can import it. And then from stable baseline, and if on Jupyter on Google Colab you want to have suggestions, just like on Jupyter Notebook. If you press tab, you have some suggestions. On Jupyter Notebook, on Google Colab, you have to write like to control plus space button, then it will pop up some suggestions for you guys. So here I'll say common dot vec underscore environment. Yeah, I need this. From this I want to import dummy vec. Yeah, great. And then from again stable baselines, I want to import the algorithm that I want to use. Previously we have used PPU and we have also used DQN, and here we are going to use A to C, right? And then we want to have some processing libraries, let's say NumPy. Then we want to have pandas as PD, and then we also want to have import matplotlib, matplotlib. So actually we want to import another thing from matplotlib. We don't need matplotlib as a whole. So from matplotlib we want to import pyplot. Yeah, pyplot as plt, just to do some data visualizations as well. So let me run this cell, and yeah, we have successfully able to import libraries successfully. So in upcoming lectures we'll be starting importing the data and doing some data pre-processing stuff. So see you next video. Alright, so the next step that we want to work on is we want to import the data. So we'll say data frame or df equals to pd dot read underscore csv, and in this file sorry, in this method we will pass the address of our data file. So where is our data file? So here is the data file. Here is how we have some GME data, and here is how it looks like. We have a date column, opening rate, high rate, low rate, and a close rate, and also volume as well. So I think our model will be much interested into opening and closing rate rather than the other variables. Also maybe it will be interested in date as well. A few dates are missing, so we'll also be taking care of that. Okay, so here is this is the file, and since I have this file in my directory, so I want to load this file into my Google Colab. So first of all I'll click on this folder, I'll click over here sample data. So I have to paste my file over here. So I'll go to my folder, I'll simply select it, and how can I drag? Okay, so I'll simply select it and I'll go over there, and here I'll go into here and I'll just paste it over here, right? So it says that it will be deleted when the runtime will be over. It's fine. Since it is a temporary memory. So here is my gme data.csv. So I'll right click over here and I'll click on copy path. So my path is copied and I'll paste it over here. Right, now I can close it. So let's say data frame dot head. Let's print its head, which means let's print first 5 records. Great, we have this, we have it with us. Awesome. Okay, now what do we want to do? We want to change the format of this date field. It is probably in string, so we want to convert it into date time format. So we will say data frame, and inside the data frame we will talk about date, right? Oh yeah. Okay, so date pd dot to date time. It is loading for suggestions. I think it will take, yeah, we got it. Okay, so date time, and in date time we'll pass data frame, and from data frame we'll pass date to it, right? Awesome. And then we'll also display the data types of the columns over here. So let's see how our date data type looks like. Okay, it says that it has, okay, it's D types, not D type. So date column is of date time, data type, and opening, high, low, close. These are of floating point values, right? So let's move on, and let's make this date field as the index field of this data frame. So we'll say data frame dot set index, yeah, and here we'll say date. Okay, and we'll also say in place equals to true. What do we mean by this? Oh, TRU. Yeah, what do we mean by this? It means that we want to make change inside the original data set, right? If in place is false, it will just return an instance of updated data set. But if in place is true, it will change the original data set, right? So now original data frame will be changed, and we'll also print the head of the original data set. So yeah, perfect. So our date has now become the index of this data set. So yeah, so we have imported the data set, we have done a little bit of pre-processing with the data, and in upcoming video, we want to train the model. We want to first of all set up the environment, and then we will start training of the model. All right, so let's set up the environment first. So here we'll say env equals to, as usual, we'll make use of gym and gym.make. Okay, so here we'll pass stocks variant 0. Since our project is related to stocks, so we'll be making use of stocks class over here. And in data frame, since we want to work on a specific data set, so as a data frame we'll pass our own data frame, right? And then also we want to set the window of the frame, so we'll say frame bound, right? So frame bound is from 5 to 100. Now what do we mean by this? I'll explain it in a while. So window size is equals to 5. Okay, so yeah, so our environment is set, our environment is ready, but what do we mean? Is there any error? It says that frame bound is not defined. Okay, so it will be defined later. Okay, fine. So window, what do we mean by window size? Okay, first of all, we have defined that we just want to work on records from 5 to 100, and our window size would be fine, which means that we just want to use 5 records as a previous memory, right? If we go back over here, so imagine this is our data set, right? This whole is our data set, and let's say our window is 3, right? So first of all, we will start from here, and we will make use of these 3 records in order to predict the next value, right? And then we'll slide the window along, and this will be the new window, right? And we'll make use of these 3 records in order to predict the next value, right? And so on. We'll be sliding the window over again by adding one more record, and so on and so forth. So that's how our actually frame bound or window size works. Frame bound should start at least from the window size, because if we will start it from 2, it doesn't make any sense. Perhaps it will give us an error, because in the beginning it will be having only 2 records, but our window wants to log into 5 records. That's why we want to have at least a window size over here, right? All right, let's run it, and oh, it says that yeah, there was an error, but what is, oh, frame bound equals to, yeah, I was right. So yeah, our environment is ready. So in the environment, let's see what are the signals in which our model will be looking. Signal features. So what are the features that are extracted in the environment? So again, signal featu Yeah, what is wrong? Yeah, spelling are wrong. So it is not signal, it is signal, right? So let's run it. Okay, so these are the signals that our model will work with, right? And or you can say these are the features with which our model will work. Another thing, let's see how our action space looks like. So action space, yeah. So let's run it. And okay, so we have discrete action space, which means we have discrete actions, or in other words, we have two actions. So let's sample one action out of it. One action is 0 and the other one is again 0, the other one is again 0, the other one is it keeps giving 0. Yeah, so the other one is 1. So we have two actions, 0 and 1. In other words, we have two actions, invest or pull out the investment. So or you can say buy and sell, right? So this is our environment space. In upcoming video, we are going to set up a random environment, just like we always do. So we are going to set a random environment and we'll see how a random model actually works. All right, so let's write down the architect of a general reinforcement learning algorithm. So we'll say environment dot reset, right? First of all, we always reset the environment, and then we'll say while true. So here is an infinite loop. It will run until we are not done. So first of all, we'll get the action, and we are going to only explore. So we'll say environment dot action space dot sample, yeah, right? And the next thing is we are going to say environment dot step, and in step we are going to pass action into it, and also it will get us what? It will get us a next state, right? It will also get us reward, it will also get us a done variable, and it will get us info as well, right? And after that, what do we want to do? We want to see if it is done, then just print the info and break the loop. That's it. And also let's add some data visualization into it, right? So we'll say plt dot figure. So our figure size should be fig size, yeah. So let's say 15 by 6, right? So this would be our figure size. And then we'll say plt dot cla, just to do that, and then environment dot. Okay, so here we want to render our environment, and we want to render all of the steps that we have taken, right? So we want to render all of the states, and then we want to do plt dot show. Great. So what are we doing? We are just taking some not some, but all of the random steps over here, and then we want to see how much and then we want to just render our environment into plt, which is a matplotlib object, right? So let's see how it works for the random actions. Okay, so here is how it works. I don't know why screen is okay. So I think it is. Oh, let me stop it, because I have done the data visualization inside the loop. I should not have done that. That's why it is visualizing it again and again. So let me run it again. I've taken it out of the loop. So here, if we see that our reward is minus 285, which is pathetic, obviously. Our total profit is 0.152. By the way, how to read the profit? If your profit is 1, you can say that it is neutral, which means that you don't have any loss, you don't have any profit. If your profit is less than 1, that is loss, and this is huge loss, right? And if your profit is above 1, it means that you have profit. So here you can see that it starts from here and it start taking some random actions. There is no logic behind it, but just some random actions, right? So here it sell a few of the stocks, and these green dots indicates that it buy some of the stocks, right? So here you can see that it was a terrible move to buy the stocks when it was at the peak, right? We should buy the stocks when they are not at the peak, when they are bottom, and we should sell sell the stocks when they are at the peak. So it has done roughly the opposite of that, and then it is buying and selling and stuff like that. In short, it has received a terrible reward, right? But no problem, no problem, it was expected because we are just making some random moves over here, right? So we just wanted to build the architect of the, or you can say the pipeline of this trading bot. And in next video we are going to train our model, and then we'll see how our model performs. All right, so let's train our model. For that, let's copy this line where we are creating the environment. So let me copy this line from here. We'll make use of it over here. Okay, so let me make it as lambda, so that we can create as many environments as we want. Although we'll not be creating more than one environment, but just wanted to do it generically. And then so this is our environment maker, and then here we'll say environment equals to dummy environment, right? Yeah, dummy vectorized environment that we used in previous lecture as a wrapper, and it will be used as wrapper here as well. So here we'll say environment underscore maker. Yeah, so we have passed environment maker into it, so it will create an environment for us. Let's run it. Right, so here we are going to create a model, and our model is A to C. And in A to C, here we are going to pass the policy. Previously we were working with an MLP policy, and here we are going to work with the MLP LSTM, which is an RNN based policy, recurrent neural network based policy. And then POLICY. Yeah, so we are making use of this policy. As I told you in last lecture as well, if you're using with the computer vision based data, or images based data, or video based data, you should use CNN based policies, right? But if you're working with statistical data, you should use RNN based policies, or you can say contextual based policies. So LSTM is a contextual based policy, right? 99% of the cases works like this, but there are obviously some special cases. So this advice is not quite generic. It is generic, but not very generic. So the second thing is we are going to pass environment into it, right? That we have created in previous line, and then as usual we are going to make verbose equals to 1. Great. And then we are going to ask our model to please start learning, buddy. Yeah, and here we are going to pass what? Total time steps. So let's run it for 100,000 steps, right? Okay, so is it 100,000? No, it is more than 100,000. So now it is 100,000. Okay, let's run it for 100,000 steps, and let's run it. Here we go, and there is an error. It says what? It says unknown police MLP. Okay, yeah, I think, yeah, this was the policy's spelling. I think we wrote L as a lowercase letter. Yeah, okay, now it is fine, right? So let's run it again. It is giving a few warnings, but who cares about warning when you're a developer, right? That's just a joke. Don't take it seriously. Okay, so here you can see that we have some evaluation matrices as well. We have explained variance, we have frames per second, we have number of updates over here, policy entropy, total timestamps, which is right now 11,000, and then we also have value loss and stuff like that, right? So it will take quite some time in order to run 100,000 steps. So meanwhile, let's do some evaluations, right? So let it run and let's start doing code for evaluations over here. Okay, so first of all, we'll be getting the environment. How can we get the environment? So we'll be obviously making environment from gym. Let me copy it from here, or perhaps you can call environment maker as well. So I'll say env equals to this environment, right? So this is the environment with which we are working, but since we are evaluating it, so let's not evaluate it on whole data set. Let's evaluate it on only from 80 to 100 frames, right? And then here we'll say state equals to env dot reset as usual. So here we are resetting the state, and then we'll say while true, while true, and then we'll say state equals to, now this state will come from the state of numpy dot new access, and then here we'll say triple dot. Probably it will give us the new state, and then we'll say action and states from the model dot predict, right? And here we'll pass the state, and it will return us the suitable action over here. No, great. So okay, then we want to take the next step. So our next step would be state and reward and done and info will be coming from environment dot step, and this step will pass the action that we have received over here, right? So the next thing we want to do is we want to see if we are done, then do what? Then print let's say print info, right? Print info, and then just break the loop. Okay, and also we want to do some data visualization that we will do. By the way, our training is still on the way, and it has trained for roughly 73,000 steps. And okay, so here we'll do some code for data visualization. So let me copy all the code for visualization that we have already done somewhere over here. Great, let's copy it, let's paste it over here. All right, great. So it has run for 84,000 steps, roughly 15,000 steps left. I'm going to pause this video and I'll come back when training is done. So we are back and our training is done. Here you can see that total timestamps are equal to 100,000 and our loss is pretty much, smaller. So yeah, looks great. And let's run the evaluation that we have written. Let's go through it again. So we are creating an environment again with the same data frame, and we are going to test it on window from 80 to 100, right? And then we are going to reset the environment, and then an infinite loop. It runs until we are done, and then we are just reshaping the state so that we can pass it into our model. We are passing it into the model. We are receiving an action, and we are passing that action into the step thing that we always do. We receive state, reward, done, and info variables, and we see if we are done, then print the info and break it, right? So let's run it. And here we go. So our total profit is 1.23. In other words, we have received a profit of 23%. Not bad. But at the same time, let me tell you and receive it as a disclaimer, this is not a financial advice. This is just a pipeline of deep reinforcement learning algorithm by using stable baseline and Gym AnyTrading environments. So I would not recommend you to invest your money um, in real by working on exactly these guidelines that I have provided. I mean, if you want to do that, sure, you can do that, but that will be at your own risk. So our total reward is 0. It's fine. We are not getting any negative reward. Not getting the negative reward is also a good thing. But the thing is, we have got 23% of the profit over here. So let's run our data visualization and let's see what was the mode of trading. So here you can see that when it was going down, it has it has sell the it has bought the stocks, and then when it was going upwards at the top, you can see that it has sell the records, which is a good move. So yeah, only with the training of 100,000 time steps, we are able to generate roughly 23% of profit on this GME data set. So this is a general pipeline. I mean, you can work with the Bitcoin data set as well. All you have to do is you just have to replace your data set over here with the Bitcoin data set or any stock related data set, and the whole process will run same for you guys, right? So play around with it. Try to change the algorithms that we are using here. We are using A to C. Try to change the policies for it. Try to change the policy architecture for it. Try to change the other hyperparameters as well. Also play around with the frame bound and window as well. So yeah, that's about it from the trading bot. We have implemented another project. I mean, in this course we have implemented a lot of projects now. I mean, that was the goal of this course, right?